Hello everyone to the talk of Vaadin and Eclipse 4 and of the project called Vaaclipse, which is the merging of the two. First, an introduction about me. I'm a software developer. I work for the International Criminal Investigation Training Assistance Program. You see there is a reason why it's short in there. Basically, I do law enforcement information systems for the Albanian State Police. I'm also an Eclipse E4 committer, a Vaaclipse committer, which is the project I'm talking about today, and the platform UI and runtime contributor at Eclipse. First, I'm going to talk a bit about the Vaadin UI framework. Has anyone here used Vaadin? Yep, only a couple of people have used Vaadin. It is a web UI framework. It's a framework used to build web software, or let's say software which runs on servlet containers. And of course it's written in Java, and it has the desktop programming model, which means it's kind of like a swing, or not like SWT. The main difference is this parenting stuff. And you can see there, you write code like you would write on a desktop UI framework. You see new button, you add listeners and stuff, but the difference is that all of this is rendered in the browser. Under the hood, this library uses SWT and converts these Java components that you see here, new button and parents, you can see here. It converts them to JavaScript widgets, which get run on the browser. They get serialized, they go to the JavaScript engine on the browser and get executed there. While we're here, I can show you a bit of code. You can see here a table, how you create a table in Vaadin. You see you have a Java class file. You're in a Java editor. You see you create it much like you would create any Java object. You set its size. You set the header mode. You say, I don't want any headers. You set which visible columns are there. You set the drag and drop stuff, and then other different stuff like is there multi-selection, etc., etc. This class here is mapped to this thing here. This is if you remember the name, the playlist view. It's this thing here. This is just a table without headers, and it doesn't have multi-selection. So basically, you write the code as a Java class. It gets compiled by GWT to JavaScript widgets, which get run on the web browser. By default, you get a bunch of default widgets, like anything that you would use in a web application. You have buttons, you have tables, you have text fields, anything that you can think of while building a web application. But also you have things like which are more natural to desktop programming, which are this thing here is the tab sheet, and with tabs. So basically, you can also create custom widgets. You can create the server side of it and the client side of it, and then you can easily integrate them in your application. And then comes the Eclipse 4 platform, because this Vaaclipse project is the merging of these two. This web UI framework, which is Vaadin, and the Eclipse 4 platform. A small overview of how the platform is organized. There are two main components: the runtime of the platform and the UI, which we call the platform UI. In the runtime, the main, let's say, component is the DI engine, the dependency injection engine, which provides dependency injection for everything happening in your RCP application. It provides linking between different components of your application. Then there are the contexts, which are the main mechanisms, which is the main mechanism of scoping stuff. Everything is organized in contexts. Every window has its own context. Every part has its own context, and this way you can scope, let's say, what you want and scope the injections that you make at runtime. Also, there are some core services in the runtime level which are not dependent on not dependent on UI. This is stuff like the event broker. The Eclipse 4 platform uses it's called the OSGI event admin. The event broker of Eclipse 4 is a wrapper around it, and it's kind of a publish-subscribe mechanism, and it's provided in this runtime level as a service. Other stuff in the core services at the runtime is the logger, the status reporter stuff, which is not, let's say, dependent on UI. And then comes the UI part of the platform. The first is the application model. It's basically an EMF model, which declaratively describes how describe the skeleton of your application, much like the Eclipse IDE, that you have perspectives, that you have parts, part stacks, etc., etc. Then there are the UI services. UI services are as a kind of services which your RCP application needs to use. They range from the model service, the part service, and they are used to manipulate the application model and to communicate through dependency injection with different components of UI and runtime. And the other one is the renderer framework, which is really important because this component in the platform UI makes it possible all this cool stuff, for example, that Tom showed you. The Eclipse 4 JavaFX stuff on Eclipse 4 is, let's say, a swapping of this renderer framework. By default, you get the Eclipse IDE, and this renderer framework translates this declarative abstract application model to SWT widgets. And what you see are actual SWT widgets rendered by this rendering framework. And an important observation here is that I think except the DI engine, at runtime everything else here is interchangeable. What you have now, let's say, in the platform is just a bunch of defaults which can be changed. And one of the things which can be changed is also the renderer framework. So you grab the application model, you switch the rendering framework, and then you have the widgets rendered in a different UI toolkit. By default, everyone who's used Eclipse has seen the SWT stuff. Tom showed you the JavaFX stuff, and now I'm going to show you how you can use this with the Vaadin stuff. So you can render this stuff actually on the web. Okay. One other point that I want to make that it's important is that when I show this to people, usually they get the idea that they're going to run Eclipse on the web. And this is a completely different thing. This is writing Vaadin applications with an Eclipse platform under it. It's a completely different thing. The code that you'll write would be Vaadin code. But rather than doing tab sheets, doing this stuff on your own with plain code Vaadin, most of it you can do it. You can make use of all these components, all these services. You can make use of the application model pattern, let's say. You can make use of the default UI services. You can make use of all the runtime services. You can make use of dependency injection, etc., etc. So you don't have to build an application from scratch without any of these, let's say, goodies. But from the moment I will show you there is a wizard, you would create with 3 clicks a working application in Vaadin which can make use of all of these components which make up the Eclipse platform. Okay. A bit of history. Some time ago, a guy who is also a committer and is the initial creator, his name is Rushan. He just came through the Eclipse forums and said, hey, I have a small problem with the event brokering system, and this problem, let's say, came up when I was building the renderer for Eclipse, the Vaadin renderer for E4. And it was really interesting. We told him, okay, yeah, we patched the event broker and stuff, but can you show us what you're doing with this Eclipse 4 and Vaadin stuff? Because at that time, I had started, let's say, playing with it, but didn't get that far because of some reason. And this guy came to single-handed build this working version, initial working version of the renderer 44. And that was kind of like a show of the power that you have in a platform where everything is just a default and you can swap it. So he showed us the code and we helped him. I got involved in the project and now we're 3 people now maintaining and let's say working on Vaaclipse, and we've been doing quite a lot. Recently we ported it to Vaadin 7, which is the latest version with lots of memory improvements, because the main issue here is the memory in terms that since everything is created on the server side, the memory footprint tends to grow, and the guys from Vaadin in the latest version have made quite a good work on optimizing that. Okay, so before I go, okay, let's. The idea here is that the biggest roadblock that we had in here is that the fact that the Eclipse 4 application platform and basically also the 3.x one were designed for, let's say, for the use case of a single user, which means that there were changes in the 4.x platform, but it was really difficult to have multi-users of the same runtime, of the same OSGI runtime. And we make this decision of doing just one runtime with multiple workbenches. Actually, if you run a Vaaclipse application now, it's just an OSGI runtime which has the Jetty bundles, which is a servlet container. And every time that someone accesses it, it creates a workbench for him. And then with a patched event broker that I told you about, then we achieve this use case of having multiple users for a single OSGI runtime. Okay. Next, I'm going to show you 2 things. I'm going to show you 2, let's say, demo applications that we have made, let's say, to show people what this is all about. And another thing that we have is tooling. We have some, if you've used the default E4 wizard, it just creates a new E4 application. And we also have a new Vaadin Eclipse 4 application for you. So in a matter of clicks, you can have a working Vaaclipse application, which is an Eclipse RCP running on the web. Okay. So, okay, this is going to be the first one because this is better. So, this is a Vaaclipse. I think it looks good, yeah. This is an Eclipse RCP application running on the web. It's this scenario here that I showed you, that everything is almost the same. The renderer framework is different. Some services here were swapped. As I told you, they are swappable. Everything here is swappable. So, and you get in here. Of course, you have all the goodies of the Eclipse platform. You can say you have drag and drop, you have perspectives, you have, I don't know, minimize, maximize, number of users on the server, etc., etc. So it's this is a kind of like we had a prototype called this sample IDE, which was a sample IDE made only with the Eclipse 4 platform, and it has some really undeveloped editor behaviors, which are in the initial stages. Let's say you can open Java, you cannot really edit them at this stage, but you can open files and stuff. So basically this is a real RCP application running on the web, provided that you have this Vaaclipse Vaadin renderer. Another one is more like because this guy looked like you got Eclipse and pasted it on the web, but the second one is a more web-like, let's say, application. It's still an RCP application. It has different, let's say, perspectives. You can see here everything. You can change the theme on the fly, which is a better. I think this one's the better. Okay, so this is another theme. You can change it on the fly. You can see easily, I think it's here, the handler. It's as easy as saying, for example, through dependency injection, set this new theme. You see here the same application is running here, which shows the multi-user support. For example, this is a different browser, this is a different session. And you see here it's the same server, it's just different sessions on the same OSGI runtime. It's just Jetty spawning different threads and making requests and spawning different workbenches. Something else that I wanted to show is, yeah, of course you can do, Rushan is really keen on soccer, and he puts all of, let's say, possible multimedia soccer things in the demos. Okay. Now I'm going to show how you can create, provided that you install the Vaaclipse plugin, which is, I will show you, is available on the GitHub project, how to create, let's say, a default Eclipse, a Vaaclipse application, and what you can, and some basic stuff that you can do with it. So this is the default one. You get the SWT Eclipse 4 application ready for development, and then this is the Vaadin one. You put in the name. Okay, let's leave the default. This is the port where Jetty is supposed to run, because it will set up the servlet container, which is the Jetty. You can use, for example, it's just like Tomcat or Glassfish. Oh, I have a working set, so. Okay. Okay, so the wizard creates a ready-to-be-run application provided that you have a target platform, which is, of course, you can download and set it really easily. It shows the message on. This is probably my IP, but I will use localhost. Okay. We have a default login provider if you want to use it. If you don't want, you can just command it out. Okay, so this is, let's say, a bare Vaaclipse application generated by the wizard. You can do all sorts of stuff now here. You can draw from the goodies of the application model. Now you can have, let's add a part in this part stack here. I'll add a part here. And I'll say third part. Let's put an icon in there. Okay. Let's put this icon. And you see I'm not even restarting Jetty for this case. I'll just go here and do restart application, login, and you see the third part in here, even without restarting the servlet container. And of course, as I showed you, you have drag and drops. You can change it and make this third part closable. I save it. you have to restart because. And you see now the part is closable, etc., etc. So, in order to understand the value, the idea is that if you had to build this with just Vaadin, then you would have to get this that you get by default with an application model, just adding it in a declarative way. You would have to do new tab pane, add tab, set the name, set the icon, etc., etc. But now you have a platform that most of this stuff you can do in a declarative way. And this is kind of a proven way of building complex application because the Eclipse IDE has been using this for 10 years or 5 years, this workbench or application platform way. Another thing I'm going to show is how you can use other elements here, which is the DI, dependency injection, to do some manipulation in the application. For example, you have this second view, which is this view here. I'm going to just add a button and change the label, but do it in a, let's add a new Vaadin button, say change the label, importing a Vaadin button, and say add a listener. And here I want the part that this button resides in, and I can get it really easily. I say the part, M part. The M part is this thing here that you declare here. And using this context that I showed you, that where the scoping mechanism, the Eclipse platform knows that this button that will be here is in this part, so when it's requested by injection, it will give you the right part, this second part here, not any of these other ones. So, import, and I would do save. In this case, I need to stop Jetty because I'm reloading Java files. With a habit of SWT, I forgot to add it to the parent because in Vaaclipse you always add the child to the parent, different from the SWT where you do it in the constructor. So the parent in this case is just this panel here, this pane in this space, and I will just do parent add component button. Oops, I think I'm out of time. Okay. Okay, you see the layout is a bit messy because I didn't declare a layout. So when you click here, it will find by dependency injection that this is the right part, and it will manipulate. When you click that button, it's just this model here being manipulated. It's like writing this down here and changing it. So by dependency injection, basically you have all the access to the UI services, to the application model, and everything else that the Eclipse 4 application platform offers by default to SWT, which is its kind of like main customer, but also JavaFX stuff, Vaadin stuff, Swing stuff can make use of this. This is, we've been using it, me and Rushan, we've been using this for the moment for some internal application. They've turned out to be, let's say, really easy to develop. We haven't tested some cases of I don't know, thousands or hundreds of thousands of users in order to, let's say, load test the memory consumption, but there are some promises from the Vaadin guys that in terms of memory footprint, the 7 version is, the version number 7 of Vaadin is really optimized. Okay, I have the last slide. If you want to get involved, this is the GitHub, let's say, project, or if you don't remember, just Google Vaaclipse GitHub, and it's the first result. Okay, so basically this is all from my side. Questions are welcome. Okay, the question is, what is the rendering engine? The Eclipse itself provides a set of bundles, which are those here, which some stuff are not resolved, and this Vaaclipse project provides bundles in order to do the translating of this application model that I showed you into widgets, of this guy here into actual Vaadin widgets. And I can show you, for example, the part renderer. It's somewhere in these bundles in here. Let's link it. Yeah. This is the presentation bundle. This is, here we are in the internals of the rendering engine. And you can see, for example, this create widget. It gets the model. This is the model, the toolbar. The toolbar is this guy here. Where is it? This guy here, the toolbar of the part. And it gets the model version. And it translates, it creates, these are Vaadin stuff. Meanwhile, these are the modeled. So you have the model and this class, there are different classes, the part renderer, the part stack renderer, etc., etc. So these bundles are the...
I'm not familiar with Vaadin. This is Java code.
Yeah, plain Java code.
It's converted to something like Google Web Toolkit.
The Google Web Toolkit is the library which converts it into runnable JavaScript code. So in the end, if you see here the source of this guy is just a bundle of JavaScript libraries. Okay. Any other question? I know it's lunch, so I understand if you do not have any questions.
So basically, you can build an application using Eclipse 4 on desktop, and then substitute the renderer and obtain a web application, isn't it?
Okay, that's the main difference that I try to make. The idea is that you, as the guy here, the renderer framework is responsible of giving you these panels here, these big things here, but from there you will have to write Vaadin code. So when you build your application, you will have all the Eclipse, let's say, independent Eclipse, independent from the UI, Eclipse services, like I showed you, the logger, the event broker, the dependency injection, but your code will actually be Vaadin code. So it's just kind of like a super-powered Vaadin application, and it's super-powered with the Eclipse 4 application behind it, the Eclipse 4 platform behind it. And it will offer you lots of everything that it offers to a desktop application. But this exchange you cannot make, meaning that you have the same code and just switching the rendering engine and have it run on the web. That's not the idea of the project. The idea of a project, in short words, is to give people who write web applications, to give them the possibility to use the Eclipse 4 application platform to make their life easier in building the application. Because this guy here was developed, I don't know, in 2 nights, because that most of it are facilities from the Eclipse 4 application platform. And if you had to do this only with plain Vaadin code, building all these toolbars and stuff, it would take way more than that. And it would be way more difficult to maintain. Anyone else? Okay. Thank you very much.